Welcome friends. Today we will be studying about multivariate analysis. This is basically an overview on multivariate analysis, and we will just look at different multivariate techniques, when which technique is applied and what are the outcome of a particular technique. We are not going to see or look into how this system works or how a particular multivariate analysis technique works, but we will look into the purpose and why it should be used, what is the outcome of the technique. That much only will be studying. Also, since we are going to cover most of the major multivariate techniques, so the presentation will be a big one. So we have split it into three parts and try to cover most commonly used multivariate tools. For beginners, let us start with having an idea about multivariate data. Multivariate data consists of information about variables and observations. So we may have more than three or more than three variables, then it comes under multivariate analysis. Two variables are called as bivariate analysis, and more than two variables consists of multivariate analysis. So we have many variables and we have several subjects from whom the information regarding those variables are collected. So those subjects are our observations. So each subject gives us information about those number of variables. So that is the concept here. So let us have a example of an all-rounder. So suppose this is an all-rounder. Name is Jack Ellis. He plays for South Africa. His age is 42. And when he played ODI, then his bowling average was 31.7, batting average 43. His batting strike rate is 73 and his economy rate while bowling is 4.83. Suppose these are some observations or some variables which are associated with this player. So variables are country, age, bowling average strike rate and economy rate. And these are the corresponding values. So what we do is that we use generally rows and columns to represent the data set, where the variables are represented along the columns and for each observation is populated along the rows. So along the rows we have values of Jack Ellis. Now if we consider another all-rounder in our system, for example this is another all-rounder we have here. His name is Ravichandran Ashwin, and these are the values. Now these values will be placed under this name is Ravichandran Ashwin, age is 32, country is India, economy is 4.81, bowling average is 27, average is 20 and strike rate is 85.9. So this way the values are getting populated. So with each additional variable, we have one new way to represent. With each additional observation, we have one new row which is been populated, but no addition to the number of variables. So this is how the data set. So I collect information about several all-rounders on these variables. So accordingly, my data set looks like this. So here are the variables and there are values under each variable. So these are my observations. Now if I want to introduce another variable, that which hand the bowler is bowling, right hand or left hand. So this is another variable we have introduced. So accordingly a new column gets populated and we will put the values under this column. So accordingly we will get some values beyond this variable. So this is how the entire multivariate data set looks like. So this is just an introduction or gives us an understanding about what is multivariate data set looks like. Now what all are the different types of analysis that we do? The general form of the multivariate data set is quite like this. So here we have p variables and we have n observations. So for each variable corresponding to each observation we have one value. So ultimately we have p into n number of values in my entire data set. Now we go and look at the graph, look at the multivariate data analysis. So multivariate data analysis, there are the dependent variables. So this is the multivariate data analysis. These are the, let us start with this starting point, that we will see a flowchart, and under the flowchart we will understand what are the different multivariate analysis techniques, when which technique is to be used, etc., etc. So first in the data set, it asks the question whether in the data set there is any any dependent variable in the data set, dependent variable or variables. So there is no dependent variable in the data set. That means we have some variables and some observations and values of the variables under these observations. Accordingly, we get these type of these are the techniques which you can apply here. What are the techniques? When the data are completely devoid of any dependent variable, this is principal component analysis, factor analysis, cluster analysis, and multidimensional scaling. So these are the four techniques which comes or which can be used when we have no dependent variable in our data set. So now, depending on the purpose, we will choose our technique. First, let us look at principal component analysis, and let us see what principal component analysis does. Now, principal component analysis is basically a data reduction technique. That means we have many variables and then we use some data reduction technique. Means basically we are trying to decrease the number of variables. But does it mean that the variables will be dropped abruptly, or following some rules some variables will be dropped? I have p variables, now I drop some variables and I have now p minus k number of variables, that is k variables I have dropped. Is it like that? No. What it does is that principal component analysis actually creates some new variables. Now these new variables created are actually linear combination of all the existing variables. So if there are p variables in the data set, then principal component analysis will generate p variables which are actually linear combination of the already available p variables. Now each of the new variable created will explain some amount of variation in the data set. So we cannot go ahead, or we shall not go ahead with all the newly created variables, but we will select some of the newly created variables. The number of principal components, how many will be retained, depends on the with the help of the eigen values associated with the variance covariance matrix of the data set. So this is a way in which it will work. The new variables thus formed are independent of each other, which with minimum information of the data set squeezed into the first few components. Sorry, maximum information in the data set will be squeezed into a first few components. So instead of taking all the components, we can take a 3 or 4 components. So ultimately your data set which had 20 variables might be concised into 4 newly created variables, which are actually linear combination of all the 20 variables, but we have them in different ways. So here is a graphical representation of the outcome of principal component analysis of a particular data set. Let us assume that in the data set there were 10 variables. One, we do the principal component analysis, we get 10 linear combination of the existing 10 variables plus the percentage of explained variation. That is, first principal component explains 42% of the variation. Second principal component explains 18% of the variation. That means if we take the sum of these two, 60% of the variation of the principal component is explained. So this is how it goes on. You see, first one 42%, second one 18%. So 42 plus 18, that is equal to 60% of the total variation in the data set is actually explained with the help of the principal components. Now this is a diagram, very interesting diagram. You see here, principal component analysis, if we want to represent it graphically, it cannot be done because graphs cannot be drawn for multivariate data set when large number of variables. But if you see, if we, this is a 2-dimensional data, that is, it has x-axis and y-axis, and some blue points are the points plotted. Now you see there is a line which is rotating around the graph. Now this is, we want to reduce 2 dimensions in 1 dimension. The red dots that you are seeing is the projection of the blue points on the line. That means if you lit a light from the top, what will be the projection of the blue dots in that line? That is what they are showing. Now let us assume that rotation of axis here, or rotation of the line, means you are changing the rotating the light source 360 degree, rotating the light source. Now you see, when the line becomes parallel to the purple line, that is this line, then the maximum scattering in the points takes place. Now this point will come here, the line rotates and becomes parallel. Now this is the point. Yes, exactly, this is the point. And here you see the scattering of the points is more, but as the line becomes perpendicular to the gray line, probably this what all the points are coming very close to each other. In principal component analysis, we want to make a transformation so that the projection of the points in lower dimension is maximum spread, variance is maximum explained, and that is how we can somehow imagine how principal component analysis works. Not exactly this way, because that is a multivariate setup, but multivariate graphs cannot be drawn with the help of coordinate axis. So just we are showing how two coordinate axes can be actually merged into one axis. Instead of having two dimensions, you are now having one dimension. So this is actually attained by rotating this particular line. This has been the source of this graph is given, as you can see the source, and this is the plotted graph practically. So that is what I was telling actually. So this is actually when this line becomes parallel to the purple line, that is this line, the projection of the points goes far apart, and that means maximum variation is explained at that point. So we are actually in search of that. So that is what principal component analysis do. It is a data reducing technique. From many variables you convert to lesser number of variables, but in this process you don't exactly go for a dropping the variables. Rather we rely on some linear combination of the existing variables, and ultimately instead of we'll get 10 variables 10 linear combination, 20 variables 20 linear combination, but we don't go with this linear combination are called components, principal components. We don't settle down with 20 principal components, rather we convert to first top 2 or 3 principal components so that the values can be. When we go to the top position, now back, okay. Now next one is factor analysis. Now let us look at factor analysis. Factor analysis is also a data reducing technique, but it deals with latent variables. Latent variables are those variables which cannot be directly measured, but can be measured through some Likert type scales, etc. So there are some scales, some statements are there in scales, and below each statement there are 5 or more than 5 or 6 or 4 number of options, which are nothing but the different levels of agreement you have with the statement. Now if you are satisfied, you will tick like so you will tick at some portion strongly agree or strongly disagree, like that. So based on the data is obtained, and on those data when you do some analysis, those variables are called as latent variables, and based on those data when you go for dimension reduction, and then actually we perform factor analysis. So data is latent type of data. Here what we do is that we classify our variables into some groups which are called as factors, such that those in one factor are relatively related to each other, and those with another factor in that is variables under two different factors will be feebly correlated to each other. So this is also done based on the total variance explained by the system using the variance covariance matrix. So let us take an example to make the thing clear. Suppose I want to measure the MBA, means performance of a restaurant, and I have some variables. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 variables I have. So I make some statements related to this and put them in a question. Like what is the not question, it is a statement, like parking facility near the restaurant is excellent. Quality of raw materials used for cooking the food in that particular restaurant is up to the mark. Music inside is not at all good. So these are some very strict statements, positive and maybe negative also. And below that there are some scale points like strongly disagree, disagree, neutral, agree, strongly agree, or some other way you can arrange it in some not more than 5 scale points, etc. Now people are answering all these 13, sorry, under these 11 statements they are answering this statement, and then we put the entire data set when collected from a large number of people for factor analysis. What it will do is that factor analysis will classify these statements into some groups, like it puts that it identifies that there are 3 factors, 1, 2, 3, and in this factor, first factor is the most important factor, second factor is little less important, and third factor is the least important factor. There may be more factors also. In this example I have taken third factor. Now you see, if you look at the variables which come under factor 1, aroma of food, quality of raw materials used for cooking, quality of water, quality quantity of food per plate, That means these elements or these variables are more important so far as food is concerned. These are more important. Little less important is related to parking facility, music, decency of the crowd. So I may give it a name ambience. And last one is smart waiters, payment option, time lapse. Okay, these we may give a name service. So these names actually the researcher has to do, the researcher has to provide studying the content under each factor. It will not come automatically. Now once this exercise is over, what I understand that when you want to study the quality of restaurant, or the people are opining, they are opining that food is the most important factor, followed by ambience, and lastly it is the service. So the restaurant, if they want to prosper, they have to give more importance to food. There are things like quality of food, quality of drinking water, raw materials should be fresh. So these are the things where they want to give more importance. So this becomes very, factor analysis becomes very important in business research, because in business research many a times, when we, more specifically market research, when you want to know the opinion of the people, we don't have a direct scale, but we have to take the help of some latent variables for measuring those satisfaction level, uh, or say consumer satisfactions, etc. These type of things we need to take the help of some such scales. Now once we do this, when we introduce factor analysis, or when we do factor analysis here, factor analysis actually classifies the variables into some groups depending on their importance. So at the end of the study, the researcher understands that what are the factors which are important and what are the factors which are coming together. Means there is some similarity with this. So this is a exercise which quite commonly used. So if you pick up any journal, standard journal on business research, we will find that few papers in most of the issues are there which has applied factor analysis. So factor analysis becomes a very important technique in this regard. So let us go to the next. So this is all about factor analysis. Now come to the next one, which is called as cluster analysis. Now cluster analysis, in a way it is similar to factor analysis, and in a way it is not similar also. In factor analysis we classified the variables. In cluster analysis we classify the observations. Now these, we have a data set, we don't have any dependent variable, we have an entire set, we don't know how they are classified, etc. But using this cluster analysis we can classify the observations into some groups. It is quite commonly used in marketing research for the purpose of classifying or segmenting your customers. Suppose you have a big shopping mall. In the shopping mall, different people are coming and they are purchasing different things. They are visiting different parts of the month. Some is purchasing bulk, some purchasing things in retail, etc. You have a way in which you keep the record of them. Generally these days they ask for the mobile number when you just want to go and purchase. They ask you mobile number. Against your mobile number, your name, age, etc. those things are stored. And then they actually, after that entry is made, so they have an idea about what all things you are purchasing, when you are purchasing, for how much money you are purchasing, like this. Now when you run cluster analysis on this data set, it will classify the customers depending on some factors, that these are the people who purchase things in bulk. They purchase mostly, say, like rice and other pulses, etc. And say spices, etc. These type of things, and they purchase in bulk. Now when there is some offer, when there is some new product launch which is related to rice, pulses, etc., or there is some new arrivals on that genre, then they can at least shoot email to SMS to you, so that you remain informed about that your favorite store from where you purchase rice, pulses, etc. are actually offering these type of facilities for the customers. Now this is more segmented or more targeted marketing than what used to happen earlier. Earlier some product, okay, you send it to everyone, so everyone gets the message. Most of them are not interested in that particular product. Now these things can be done quite classic. Now this is a supervised learning technique. Sorry, unsupervised learning technique. In unsupervised learning technique, we don't have anything which has been classified earlier in your data set. No classification done in your data set. Just you have some plain data. Just go ahead and do and work with it. So when the clustering is been done, similar observations are put in the same cluster. and dissimilar observations are placed in different groups. That means in any cluster you will find that there are similar type of customers are there, and that's why what I was telling that it can be utilized for making the component, making the cluster uh, or targeted marketing, because you have similar types of customers in the group. Cluster analysis, there are different ways of doing cluster analysis technique. There is independent component analysis. There is genetic algorithm which can be applied for cluster analysis. There are hierarchical classifiers, and there are k-mean clustering. So these are the four commonly used methods of cluster analysis that we will encounter when you deal with multivariate data. Now, for example, we take an example. While digging an earth, an anthropologist finds several human skeletons. Now, the anthropologist measures different aspects of skeleton like arm span, head length, femur length, space of vertebra, etc. So, he measures all these things. Based on the information on the variables, the anthropologist wants to categorize the skeleton. So, anthropologist is digging somewhere. There he found under the ground several human skeletons. Now he is measuring, and then he wants to classify them into some groups, measuring different aspects like head length, arm span, femur length. Femur length is the longest bone in our body. It's a bone from the hip to the knee. So that is the shape of vertebra. That means the spinal cord. And so he is grouping similar type of skeletons are grouped. Means in one group there will be a skeleton of children, another group skeleton of woman, another group skeleton of man. So these you can do with the help of cluster analysis, not just by visual inspection, but when he has large data set, lot of variables, lot of observations, he can use this to get the cluster analysis. Skeleton belongs to two different clusters, are will be different from each other, and skeleton belonging to one cluster will be quite similar to each other. So that is how cluster analysis can be utilized. This is an example from a field of science called anthropology. And next, let us look at multidimensional scaling. This will be the last of our agenda for today's for this version of the video. That is, it deals with a process that provides visual representation of the data set of multivariate observation in a lower dimensional plane. Very simply speaking, it is like this. You see, if you hold your hand below the light of your room, light source, I assume that there is a bulb in your room. Below that you place your hand. Now what you will see that in the floor you will see the image of your hand. Now when you offer your hand below the bulb, actually your hand is in a three-dimensional plane now. Now when your shadow falls in the ground. That means a three-dimensional, something which is in the three-dimensional plane is converted or projected into a two-dimensional plane, and that is what is called as dimension reduction. So what we do, we have a lot of observations, lot of variables. Now all these observations we want to plot in a graph, but that graph will be a lower dimensional graph, specifically a two-dimensional graph. Though the number of variables may be p, that means maybe 5, 7, 8 or 10. So there, if it is 10 variables, then it is a 10-dimensional data. Now that 10-dimensional data, each observation is having 10-dimensional data, that is to be projected into a two-dimensional plane. The representation helps us to infer about the distance between each observation from the other. This is called multidimensional process. Starts with the computation of the distance matrix, which provides the Euclidean distance between observations of the data set. Euclidean distance is a simple measure with the help of which we can find the distance between two points with two coordinates, or 3 coordinates, 4 coordinates, 5 coordinates. Formula remains almost the same, only the number of variables, their difference, and we square up the difference and take the sum of those squares. So that is the Euclidean distance. So Euclidean distance is being used to measure the distance between observations which are having a multivariate data set, and then we find out who are closely related, who are closer to each other. So that is what is done with this. Accordingly, each multivariate observation can now be visualized as a scatter plot in a n-dimensional. Multivariate can now be visualized as a scatter plot in a two-dimensional plane, not n-dimensional plane. It should be a two-dimensional plane. So if you look at this, so you see these are different profitability analysis. These are some terms related which measure the profitability of an organization. And here there are some cement companies, Ultra Tech Cement, ACC, Ambuja, etc. So there are so many cement companies, and these are different variables with the help of which we can measure the profitability of this. Now, what actually this will do, this multivariate scaling, it will this is having 5 variables, data set observations with 5 variables. Each one is having 5 variables. It will convert this 5 variable data set into 2 variable data set and will try to plot them. So here we have JK, ACC, rain, all these things, and then we are plotting this in a two-dimensional plane. Data which is actually having 5 dimensions is plotted in a two-dimensional space. Now we have look like this. Now based on this we can actually classify them. We can understand that okay, these are the companies which are quite similar because they are nearer to each other in terms of their distance. This is also another group we can tell which is actually nearer to each other, and all this is another, and JK is quite differently positioned. It is not nowhere near to any one of them, quite far away, so it is something different. So this way we can take the help of multidimensional scaling, and we can also find out that how far JK is from ACC, how far JK is from Birla, and JK and India, they are quite dissimilar, but we are seeing it, we are visualizing it in a two-dimensional plane, which is actually taking place in a five-dimensional plane. So that is the concept of multidimensional scaling. So we go back, and this is the time when we need to take a break, and hope to meet you soon with the second part of multivariate data analysis. We'll take an overview of all the multivariate data analysis techniques. Till then, wait for me and keep thinking about multivariate data. Thanks for watching this video.